Sketch a rough graph of the polynomial function f of x maps to 4 times x plus 1 cubed times x minus 1 squared times 2x minus 5. So the polynomial curve is given by y equals 4 times x plus 1 cubed times x minus 1 squared times 2x minus 5, and that's really to the power of 1. So if we add up our powers, we have 3 plus 2 plus 1. 3 plus 2 plus 1 is 6, so we have a degree 6 polynomial. So first we need to gather some information about the curve. So the degree is 6 and the leading coefficient is positive. So we have 4 at the start as positive. Thus, both arms of the curve go up. So since we have positive number in front, our coefficient in front is positive, both arms of the curve go up. So then we're going to take each of our set of brackets, each of our factors, and we're going to let them equal to 0 to try and find our roots. So let's start with x plus 1 cubed. So the polynomial has the following roots. X plus 1 cubed is equal to 0. So x plus 1 is going to be equal to the cube root of 0, which is just 0. So x is equal to minus 1. So this is a triple root. It has a multiplicity of 3 because it was to the power of 3. Then we're going to take our second factor, which is x minus 1 squared, and we let that equal to 0. So we get x minus 1 squared equals to 0. So the squared comes over to the other side, becomes the square root. The square root of 0 is 0. So we end up with x minus 1 is equal to 0, so x is equal to positive 1. This is a double root with a multiplicity of 2, because we have to the power of 2. And then we take our final set of brackets, or our final factor, which is 2x minus 5. We let that equal to 0. The minus 5 comes over the equal sign, becomes positive 5. And 5 divided by 2 is 2.5, or 2.5, so x equal to 2.5. This is a single root. It has a multiplicity of 1, because it was 2x minus 5 technically to the power of 1. So it's a single root with a multiplicity of 1. Part 3. At each of the roots, draw the right shape for the type of multiplicity. So at the roots, x equals minus 1, x equals 1, and x equals 2.5, we need to draw the right shape for the type of multiplicity. So at x equals minus 1, we have a multiplicity of 3. At x equals 1, we have a multiplicity of 2. And x equals 2.5, we have a multiplicity of 1. And then the last part, we connect these sections of the curve in a systematic way. Okay, so the degree is 6 and the leading coefficient is positive, thus both arms of the curve go up. So we can see in our curve, the left arm goes up and the right arm goes up. So we got x is equal to minus 1, and we got it to be a triple root, which means it has a multiplicity of 3. So if the multiplicity of a root is an odd number greater than 1, then the curve crosses the x-axis at the root, but levels off as it does, causing a kink in the curve. Okay, so let's have a look at our x-axis. Here's minus 1. And we know that our curve is going to cross the x-axis at minus 1. But it's going to level off and cause a kink. So we can see that it's quite level at x equals minus 1. And this produces what's known as a kink. And remember, to the left of that, our arm has to go up. So our arm is going up. So technically our curve is coming downwards because our arm is up. And it crosses our x-axis at minus 1, but it levels off, so it's like a flat top or a kink. And then it starts to move on down. Okay, so then we also got x to be equal to 1. This is a double root with a multiplicity of 2. If the multiplicity of a root is an even number, then the curve just touches the x-axis, i.e. it has a turning point at the root on the x-axis. The higher the multiplicity, the flatter the curve at the root. Okay, so we just have a turning point here at x is equal to 1. And since we have a multiplicity of 2, that's not very, very high. We don't have a really flat curve. So if this number was higher, if we had a higher multiplicity, like 4, 6, 8, and so on, it would be a flatter top here. But since it's quite a low multiplicity, it doesn't really level out. So we have a turning point at x is equal to 1. Now we don't know how far down our drop has to go in between -1 and 1. And it doesn't really matter since we're doing just a rough sketch. Notice that our y-axis doesn't need to be labelled. So we don't know at what point it crosses the y-axis at. All we know is that we start up in the left-hand side with the arm in the air. Our curve comes downwards. It crosses at -1 and it levels off, so there's a kink, so it gets lower. But then it goes up again and we have a turning point at x is equal to 1. So this is where we are so far with our curve. Okay, so we also found x to be equal to 2.5. This is a single root with a multiplicity of 1. If a root has a multiplicity of 1, then the curve crosses the x-axis directly at the root. So we go to 2.5 in our x-axis, which is around here, and we have to cross our x-axis directly at that point. So it goes right through the x-axis. And then we're left with our arm shooting up into the air. So we know that both arms go up because we had a 4 in front of our function and it was positive. So we know that both arms go up. At x equals -1, we cross the x-axis and it levels off, forming a kink. At x equals 1, we have an actual turning point at x equals 1 on the x-axis. And at 2.5, the curve crosses the x-axis directly at that root. So the graph of the polynomial function f of x maps to f of x of degree 5 is shown below. So here's our function, and it's called y equals f of x, and it is degree 5. And we are asked to find an expression for the polynomial f of x. So it's important to note first of all that if a root has a multiplicity of 1, then the curve crosses the x-axis directly at the root. So notice that our curve crosses directly at 3 and at 2 also. And notice that it crosses at -2, but that it levels off and there's a bit of a kink. Okay, so from the graph there are 3 roots. -2, 2, and 3. But because the degree is 5, there should be 5 roots. 2 and 3 are single roots because they cross directly at the root. Thus, -2 must be a triple root because 5 minus 2 leaves us with 3. So -2 must be a triple root because these are single roots, which means they have a multiplicity of 1. So they are already to the power of 1. Because the right arm goes down, so you can see this right arm goes down, the left arm goes up, the leading coefficient must be negative. So -2 is a triple root. Thus, x plus 2 cubed is a factor. 2 is a single root. Thus, x minus 2 is a factor, or you could say x minus 2 to the power 1. And 3 is a single root. Thus, x minus 3 is a factor, or you could say x minus 3 to the power of 1. Thus, we can write f of x equals k times x plus 2 cubed times x minus 2 times x minus 3, where k is an element of the real number set. As the leading coefficient is negative, let k equal to -1. Thus, one expression for f of x is f of x equals minus x plus 2 cubed times x minus 2 times x minus 3. Part 2. If the curve contains the point 0, minus 96, find the equation of the curve y equals f of x. So we have a point on the curve that we're going to substitute into the equation or the function that we made in part 1 so that we can find out the actual equation of the curve. So let the equation of the curve be y equals k times x plus 2 cubed times x minus 2 times x minus 3, where we know that k is negative because we have our right arm going down and our left arm going up. So we know that k, our coefficient in front, is negative. So to find the value of k, we're going to swap the y for minus 96 and swap each of the x's for 0. So we end up with minus 96 equals k times 0 plus 2 cubed times 0 minus 2 times 0 minus 3. So we bring down the minus 96. 0 plus 2 gives us 2. So you end up with k plus 2 cubed. 0 minus 2 is minus 2. And 0 minus 3 is minus 3. So we have minus 96 equals k times 2 cubed times minus 2 times minus 3. So 2 cubed is going to be 8, because 2 by 2 is 4 by 2 is 8. 8 by minus 2 is minus 16. And minus 16 by minus 3 is going to be positive 48. So get minus 96 equals 48k. So minus 96 divided by 48 is going to be minus 2. So k is equal to minus 2. Thus, the equation of the curve is y equals minus 2 times x plus 2 cubed times x minus 2 times x minus 3. We've got k equal to 2, so we swap that k in front for minus 2.